If you're watching this, congratulations. It hasn't happened yet. Somewhere in the universe right now, there might be a bubble forming. Not a soap bubble, not a space bubble. A bubble of pure destruction expanding at the speed of light, rewriting the laws of physics as it goes. And the worst part, if it's heading toward us, we'd never see it coming. Because it arrives at the exact same speed as the light that would warn us about it. This is false vacuum decay, and it is, without exaggeration, the most terrifying idea in all of physics. Cosmo, stop wagging your tail. This is serious. So let's talk about how the universe might just control, alt-delete itself. To understand vacuum decay, we first need to talk about something that sounds boring, but is secretly the most important thing in the universe: empty space. You'd think empty space is just nothing, a void, the absence of stuff, but it's not. Modern physics tells us that empty space is actually full of invisible fields. Think of them like a calm ocean covering every inch of the universe. You can't see the water, but it's there. And everything, every particle, every force, every atom in your body is a ripple on the surface of these fields. The most important of these fields is called the Higgs field. You've probably heard of the Higgs boson, the particle they found at the Large Hadron Collider back in 2012. That particle is a ripple in the Higgs field, and the Higgs field is responsible for giving mass to every massive particle in the universe. Without it, electrons would fly apart at the speed of light. Atoms couldn't form. You wouldn't exist. Cosmo wouldn't exist. Nothing would have weight. It'd be a cosmic nightmare. Now here's the thing. The Higgs field, like any field, has an energy level, and the universe as we know it depends on that energy level staying exactly where it is. All the laws of physics, all the constants, all the rules that let matter exist, they're calibrated to this specific energy state of the Higgs field. And the question that keeps physicists awake at 3 a.m. is this: is that energy level at the bottom, or is it just resting on a ledge? Imagine a ball on a hillside. At the very bottom of the hill, the ball is in what physicists call the true vacuum, the lowest, most stable energy state possible. It's not going anywhere. It's happy. It's settled. Kind of like Cosmo when he finds a sunny spot on the floor, completely at peace, zero intention of moving. But now imagine the ball is sitting in a little dip partway up the hill, a shallow valley. It looks stable. From the ball's perspective, it feels like the bottom, but it's not. There's a much deeper valley further down. The ball just doesn't have enough energy to roll over the ridge and discover it. That dip? That's a false vacuum, stable enough to feel permanent. But one good push, or one random quantum fluctuation, and the ball rolls over the edge and falls to the real bottom. Our universe might be that ball, and the push might have already happened somewhere we can't see. Here's where it gets unsettling. If the Higgs field is in a false vacuum, then at any point in any location in the universe, a tiny region of space could spontaneously tunnel down to the true vacuum. This wouldn't require a cause. No asteroid, no collision, no mad scientist with a button, just a random quantum fluctuation, the universe rolling dice like it always does. And one of those dice comes up wrong. When that happens, a bubble of true vacuum forms. Inside that bubble, the Higgs field is at a different value, and in that region, the laws of physics are fundamentally different. The masses of particles change. The forces between atoms change. Chemistry stops working the way it should. Matter as we know, it can't exist. And that bubble starts expanding at the speed of light. Everything it touches gets rewritten, not destroyed in the fiery, explosive sense. More like overwritten. Imagine a Word document and someone selects all and pastes a completely different language over everything. The page still exists, but none of the words make sense anymore. That's what happens to matter inside the bubble. Atoms don't explode. They just stop being atoms. The rules that held them together no longer apply. Cosmo just yawned, by the way. He's not worried. He's never worried. I envy that dog. Now, let's talk about what Max and Cosmo would actually experience. And I'll save you some anxiety up front. The answer is nothing. The bubble wall moves at the speed of light. Light is the fastest thing in the universe. It's literally the speed limit of information. So no signal, no warning, no measurement could ever get ahead of the bubble to tell you it's coming. You can't see it. You can't detect it. You can't outrun it. One moment, Max is sipping coffee in the cockpit. Cosmo is chewing on a wire he definitely shouldn't be chewing on. Everything is normal. The next moment, the fundamental constants of their atoms change and they stop being valid configurations of matter. No pain, no flash, just done. It's the most merciful apocalypse imaginable, and also the most terrifying, because you'd never know it was coming. You know how people say, at least I'd want to know? Yeah, the universe doesn't care what you want. So here's the obvious question. Are we actually in a false vacuum? Is this a real threat or just fancy math? The honest answer is, we're not sure, but the math is uncomfortable. When physicists measured the mass of the Higgs boson at 125 gigaelectron volts and combined it with the mass of the top quark, they could calculate whether the Higgs field is stable, metastable, or completely unstable. And the result landed right in the metastable zone. Not confidently stable, not rapidly unstable, just precariously balanced, like a glass on the edge of a table that hasn't fallen yet, but makes you nervous every time someone walks past. Or, more accurately, like Cosmo sitting next to a table full of food. Technically, he's behaving, but you wouldn't bet money on it lasting. Now, metastable doesn't mean doomed. The estimated decay time, the average time before a false vacuum would spontaneously decay, is incomprehensibly long. We're talking timescales that make the age of the universe look like a coffee break. The universe is 13.8 billion years old. The estimated false vacuum lifetime could be 10 to the power of 100 years or more. That number has more zeros than atoms in your body, but very unlikely isn't impossible. And the universe is very, very large. There are a lot of places where that random quantum fluctuation could happen. A bubble could have formed 10 billion light years away and be racing toward us right now. We'd have no way of knowing. Sleep tight. But wait, can we trigger it? Can some experiment, some particle collider, some future technology accidentally poke the Higgs field hard enough to start the collapse? This is a question people genuinely ask, and physicists have genuinely studied it. In a 2025 survey of 20 experts, the mean estimate for the chance that vacuum decay could be artificially triggered with arbitrarily advanced technology was about 19%. A slim majority said the risk is negligible, but a substantial minority said it's not impossible. However, and this is important, nature has already run experiments far more violent than anything we could build. Cosmic rays slam into particles in the upper atmosphere at energies billions of times higher than the Large Hadron Collider. And they've been doing this for billions of years, across the entire universe, on trillions of planets and moons and asteroids. If high-energy collisions could trigger vacuum decay, it would have happened long before we showed up. So the LHC isn't going to end the universe. The universe has been stress testing itself for 13.8 billion years and hasn't broken yet. We're just the arrogant species that thought our particle smasher was impressive. Cosmo could slam his head into the LHC at full speed, and the worst thing that would happen is a very confused security guard, which honestly sounds like something he'd do. And here's something genuinely mind-bending that we only learned recently. Scientists aren't just theorizing about vacuum decay anymore, they're simulating it. In early 2025, a team from the University of Leeds and Forschungs Zentrum Jülich used a 5,564 qubit quantum annealer to simulate false vacuum decay and observe the formation of true vacuum bubbles. They actually watched tiny analog bubbles nucleate and expand in a quantum system, confirming that our theoretical models of how this process works are on the right track. And separately, a team in Italy had already created ultra-cold atomic superfluids, sodium atoms cooled to less than a millionth of a degree above absolute zero, and observed bubble nucleation in a false vacuum state for the first time. They saw the bubbles form. They measured how long the false vacuum lasted. They confirmed it matched the theoretical predictions. We're simulating the end of reality in a lab, and the simulations are working. That's either incredibly exciting or deeply unsettling, depending on your personality. Max finds it exciting. Cosmo finds it nap time. Personally, both. So now for the part that actually matters, the part that separates this from clickbait nightmare fuel. Here's the thing about false vacuum decay. It's not really a story about the end of the world. It's a story about how fragile the word permanent really is. We look at the universe and we see constants. The speed of light, the charge of an electron, the strength of gravity. We call them constants because they feel eternal, fixed, written into the source code of reality. But false vacuum decay whispers something different. It says, what if these aren't constants? What if they're settings? What if the universe is running a particular configuration of physics, and that configuration could change? Not because anything went wrong, not because of a bug, just because the universe found a lower energy state and settled into it. The way water finds the lowest point in a landscape. The way Cosmo always finds the lowest spot on the couch. It's not personal. It's physics. That doesn't make our universe meaningless. It makes it specific. It means the physics that allows stars to burn, planets to form, and you to exist is not generic. It's a particular, delicate, remarkable arrangement. And it might not be the only one possible. Every atom in your body exists because the Higgs field happens to be in the state it's in. If it were in a different valley on that energy landscape, you'd be something else entirely, or nothing at all. You are the product of a very specific configuration of reality, a configuration that has held steady for 13.8 billion years. That's not fragility. That's resilience. The universe has been balancing on this ledge since the Big Bang, and here you are, made of stardust and stubbornness, worrying about it. So, could the universe end because empty space decided to find a better deal? Technically, yes. The math allows it. The physics permits it. A bubble of true vacuum could be expanding somewhere right now, rewriting the laws of nature at the speed of light. But the timescale is so enormous, so incomprehensibly vast, that you, your great-great-grandchildren, and every civilization that will ever exist on this planet will almost certainly never encounter it. And even if you did, you wouldn't know. It would arrive at the speed of light, and you'd simply transition into whatever comes next. No suffering, no warning, just a cosmic software update that you were never meant to see. The universe might be sitting on a ledge, but it's been sitting there for 13.8 billion years. And in all that time, it built stars, galaxies, planets, oceans, and eventually a guy in a flight suit and his golden retriever floating through space trying to understand why anything exists at all. Max looks at Cosmo. Cosmo looks at Max. Cosmo licks his helmet from the inside. If that's not worth sticking around for, I don't know what is. If this video made you look at empty space differently, subscribe. Next week, Max and Cosmo are visiting a universe without a sun, and only one of them is going to panic about it. Hint, it's not the dog.